Hey guys, this is my first video of TensorFlow series, and today I'm going to begin you with some basics of machine learning and some basic differences between machine learning, deep learning and artificial intelligence. So before continuing, considering subscribing to my channel, I'm trying to give a corporate level knowledge on how machine learning and deep learning is used in corporate companies like Cisco, Google, Amazon. Now this video mainly consists of difference between all these different techniques like AI, ML and deep learning. Also it will give you an overview of different types of machine learning and deep learning. Also it will give you an understanding on when do you use machine learning versus when do you use deep learning. Stay tuned. Picture gives you an idea about how is ML different than AI and deep learning. So whenever we talk about artificial intelligence powered application, that can be a mixture of deep learning and machine learning plus some other hardware components like sensors, etc. Now what do you understand from this graph? This graph tells you like, hey, whatever deep learning you do is part of machine learning, and whatever deep learning and machine learning you do is part of artificial intelligence. Okay, this picture gives you an overview of the major difference between ML and deep learning. Now, whenever we talk about machine learning, we have to extract the features by ourselves. What is features? Features are nothing but the columns which you feed to the algorithm. The columns which we want to feed to algorithm, we are the one who decide, hey, now imagine we want to predict if it will rain tomorrow, and there are some XYZ number of columns. You have to decide by yourself, hey, which column should I include when I feed to an algorithm. But when it comes to deep learning, the neural networks or deep learning have their own capacities to identify which columns are necessary and which columns are actually giving you results. Like which column, if a column is not mandatory, or if the column is not contributing to a prediction, the neural networks or the deep learning architecture will ignore it, or it will give a weight which is very close to zero so that they do not play a role in predictions. The next question arises is, when do you use machine learning, when do you use deep learning? This is a very confusing question for a lot of newbies here, but the answer for this is very simple. So guys, when everyone started using machine learning, there were a lot of prerequisites needed to start with machine learning, like you have to extract the data, clean the data, you have to select only those columns which are needed for your task. Now there is no hard and fast rule like, hey, these columns are actually helping me predict something, but that was a very tedious task, and sometimes what machine learning engineers do is they select a wrong column and they feed it into model, and virtually the whole system collapses. Your machine learning model doesn't work in production. To overcome all these things, and with this fast growing world with a lot of images, with a lot of audio files, with a lot of video files, machine learning techniques, or I can call the algorithms which we use in daily life, like logistic regression or linear regression, these are not compatible with these type of data. So the deep learning came into existence mainly for the audio data, the video data, and I can call them a moving data, the data which is having more than one dimension. I hope you got an overview of the difference between where ML should be used and where deep learning. Now all the ML tasks like forecasting a sale of a house, finding out if your girlfriend will accept your proposal or not, these can be done using deep learning as well. But for these type of a task which doesn't need severe computations, always sticking to machine learning is a very good choice. Only when you have some high computation tasks like image processing videos, creating subtitles, or predicting the next word in a sentence, only these type of tasks actually need deep learning. So if your task is simple as like forecasting the iteration, or probably forecasting some continuous values, you can stick to machine learning. So next thing, very important, you have to know is what are different type of machine learning or deep learning. This is a very common topic nowadays, and I'm sure you'll know this. There are three types of machine learning or deep learning. One is supervised machine learning, second being unsupervised machine learning, and third one is being reinforcement learning. So starting with reinforcement learning, the game which you see here is a reinforcement learning. So what is this game about? Whenever you start playing a game, there is you and your computer. You have your own intelligence to play. Hey, you see a obstacle there, you just jump it. But how will computer understand this? The technology or the technique of making computer understand what to do when is achieved using reinforcement learning. Next, what is unsupervised learning? Unsupervised learning is as simple as you throw things and you just organize. The algorithm just organizes that into similar objects. The best example will be, imagine you are playing cricket and you want to segregate the best batsmen, the best bowlers and the best fielders. So you do not know who is the best bowler, who is the best batsman, etc. So now making a separate clusters of, hey, these people are best batsmen, these people are best bowlers, these people are best fieldsmen. This method of clustering people or clustering things are called unsupervised learning. And the last thing and the main thing is supervised learning. Now supervised learning has two types of subcategories. One is classification, another one is regression. So what is the difference? So in regression, we try to forecast a continuous value. For example, you are going to play a cricket today, and what is the score you may make? You might hit a century, you might be out for 0, or you might be even hit a double century. So this technique of predicting final value is called regression. So next technique is classification. So what is this classification? Now you see a pretty girl, you go and propose her. There are two chances. One is either she'll reject it or she'll accept it. Now this is called classification. Classification always has fixed set of output values. Now you may tell me, like, she might hit you. Yes, that comes under semi-supervised machine learning algorithms. And we are not going to stress a lot on semi-supervised machine type of algorithms. Now we will be mainly concentrating on supervised, unsupervised, and a little less on reinforcement learning. I hope that video was helpful. My next video will be specifically on TensorFlow 2.0 and various applications and some real-world practical cases using TensorFlow 2.0. Stay tuned, guys. Do subscribe and share. Thanks for watching.